6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome, and welcome out here this great afternoon that you're taking out of your time, summertime. Yeah, it's great, isn't it? And we're going to do a little Mathline today, all right? So I'm Ernie Roberts. I'm your host for Tea and Learn Mathline. That's what you tuned into. And hang with us. We're going to be doing some fun stuff today. We're going to be looking at math. What else more fun could you ask for? We're also going to go back and review times tables a little bit through some applications, a few fractions, a few decimals. It's summertime. The problems hopefully will be easy, but for those of you who struggle with these, this is a good time to get some remediation. And you know what? So you'll be ahead of your class next year when you start back in the fall, back to school. We hope you're doing that. Now, as I said, it's not a call-in day today, so sit back, get you some pencil, get you some paper, let's work some math together, let's have a little bit of fun with it, and let's learn a few things, all right? Let's pick up a few things, and if nothing else, just review and get it back in your brain. Get it back on those front burners, I like to say, and we'll be ready for fall. It's not that far away. It's just the beginning of summer. Please relax and enjoy it, but let's do some math, all right? First problem, let's take a look at it here, guys. What have we got going here? Actually, what's our topic today might even be better to find out. What's our topic going on here? We're putting it together. We're pulling things together, all right, here at Tea and Learn Mathline Summer School. I get so excited addressing, and it's just the beginning of the show. Sometimes I forget when I've got to go to the topic. But anyway, also we are mentioning that, yes, you can still send us Mathline at tandlearn.org. You can still send us questions. You can also love us, like us, do all sorts of good things to us on Facebook. We love it when you do like us there, all right? But be sure to check us out at also our Facebook pages. But today, let's do some math. Now we're ready to go. Now let's simplify. Let's do some fraction decimals, all sorts of good things. Let's see what our first problem is all about here. It says simplify. I like it. Love to simplify. And you've got a lot of decimals running through here. And you've got some x's. That means multiplication this time. This is pretty much straight multiplication. There's a plus, there's a minus. Oh my goodness, what do we do? What do we do? And when simplify means we want to come out to one final pretty answer. And hopefully that will be pretty. All right, we're going to find out. We're going to find out. So, my dear Aunt Sally comes to mind here because we got multiplications, we've got additions, and a subtraction. All right, so all those things are mixing and mingling. Let's see. My dear Aunt Sally always says do multiplication and division first. And it's always a left to right case. In this case, it's all multiplication, but we're going to spot them. I'm going to underline them so we separate those little problems out, and then we'll do an addition, and then we'll subtract. Okay, very simple. Works that way in the end, all right? Again, multiplication and division first, then adding and subtracting. I am amazed at how many people don't realize that that's an important part of it. We don't just go along and multiply, add, then multiply again, and then subtract and multiply. We don't work that way. We have to do it as the order of operations state. So let's go right here to our multiplication. Hey, remember times tables? I told you we're going to be using those a lot today. So let's talk about it. 6 times 8, first of all. Don't worry about the decimals. We'll catch them in just a second. But 6 times 8, of course, gives us, you got it, 48. You know that. By the way, 8 times 6, you want to use commutative property on that. It works also. Now, let's go to this 7 times 7. It's going to be a 49. We'll get the decimals in a minute. I know some of you are going, he forgot the decimals. We're going to come back to them. Hang on. And then over here we've got 6 times 7, which is 42. I want you to first of all notice the hardest part of this thing is the decimals. No. Is hardest part is multiplication? No. None of it's hard. None of it's hard. If you know your multiplication facts, your multiplication tables, and you know how to count decimal places. So let's count them since we've got this going. We've got one place to the right of 6 and one place to the right of 8. That's going to give us 2 decimal places, which gives us 48 hundredths. Now some of you say, Ernie, I don't know and I believe that. I thought it would be 4.8 or 4 8/10. Well, let's take a look at it real quick right underneath there. I've got a little bit of room to spare. We got 6/10 and we multiply times 8/10. That's what that says. All right, let's just play it as a fraction. You know what's going to happen when we multiply 6 times 8? We get 48, da-da. But we have 10 times 10 underneath, which gives us 100. Folks, it doesn't give us 4 8/10. It gives us 48 hundredths. So that's important. That's important. So for those of you who are kind of wondering, why did you put 2 decimal places there? Because we count off. We count off the places to the right, total them up, and we move the decimal back in. Refresh your memory, all right? Now, just knocked everything off there beautifully. How about it? Let's see where the decimal's going to go here. I've got two places to the right. Let's put a decimal and a 49 right there. And how about a plus between them? We'll take care of that plus here in just a second. Remember, we come back and add and subtract at the very end. Here we got a minus going. I'll go ahead and put it down there. And again, two decimal places. So we're going to have 42 hundredths. Now, this was our little help to get us started there to make sure everybody understood where did that come from. Same story here. It would be 7/10 times 7/10, 6/10 times 7/10. You see where I'm going on this. Not that difficult, all right? Now, at this point, so we're going, do we count off decimals again, Ernie? No, we don't. We're going to put the 48 hundredths and 49 hundredths. We'll line them up because that's what we do when we add or subtract, all right? So we're going to add them up. That's going to give us, looks like 17 going there. Put a 1 right there. Remember, we're doing back to the basics this week, so it's all about the basics still here. And we got 9, and I have a decimal right there. Line it up, all right? So 97 hundredths. But we're not done, are we? We're going to subtract 42 hundredths. And my friends, we do the same thing here. We do the same thing here. We're going to subtract it. It's going to give us, it looks like, y'all out there with me? Tell me where we're going to go. This is easy. No borrowing, is there? So put a 5 right there, 5 right here. Bring your decimal straight down. There is your final answer. Now, you know me. Do you? Yes, you do. I like to do it. I like to work it out on paper. I like to do it like this. I hope this part was mental, okay? In fact, some of the addition and subtraction, probably some of you can do mentally. Wonderful. Let's do a quick check on the calculator. I always like to go back there and let's see what happens. All right, guys, can you take me to the calculator for it? There we go. How about it? We've got 6/10. We're going to multiply it times 8/10. But we're not going to stop there. We're going to go ahead and put a plus right there in between it because graphing calculators, these TIs are wonderful, as most of the graphing calculators are. You can put all sorts of computations in there and it'll just go zing. Zing. And how about it? We'll put a decimal 7.7 or 7/10. Multiply that times 7/10. By the way, your calculator does know order of operations. That's the beauty of it. Put a subtract symbol. Be sure you put subtract, not the negative. And then we've got, how about it? 6/10 again times 7/10. It's a mouthful on this great afternoon. That's a strange place where the decimal ended up, but it should still work. Press it. We've got 55 hundredths. Yes, we do. All right. So again, calculator can do it, but you know, it took me a while to put all those decimals and make sure they were right and stuff. Let your brain do the work. Let your brain do the work. Your brain is as good a calculator as that thing is on these basic math, arithmetic facts. And if you know your times tables, life is good. Life is good. All right, we played some decimals. Let's do some fractions here, all right? Everybody's going, ugh. Yes, let's do some fractions. This one says, which is greater, 6/7 or 5/6? All right, so let's play with this a little bit. I look at that and I say, well, you know what? I don't know which is greater. Actually, I do, because I've already worked the problem out. But how do we do that? What are we going to do? We need to have a common denominator right down here. Now, think about it. Think about it. How do we get there? We've got to multiply 7 times 6. Now, while your buddies are already knowing 7 times 6 is what? You got it? 42. Some of you are going like, do I need to go to the calculator? Nope. Do I need to write 7 down 6 times or 6 down 7 times? Woo! And then add them together? Nope. Know your facts. Know your facts. That's what this has been about. Back to the basics. Get those multiplication tables down so we can pull it together, all right, and work this well. So what do we need? We need 42. And then we're going to compare. We're going to see. I'm going to work this on the left side, right side, and all that good stuff. Over here, let's start off. We're going to multiply by 6. All right? Going to multiply by 6. Why did I do it? Because I need a number both the 7 and 6 will go into. Easiest way to find the least common denominator is multiply the denominators. And especially when they're 1 unit apart, it'll always be a least common denominator. Now, if that had been a 6 and a 4, you'd have a different story, all right? But since they're 1 unit apart, you can always multiply them. You're going to get an LCD right there. Now, what did I do? I did times 6 in the denominator, right? So I'm going to do it to the numerator also. Numerator, remember, is the top. Denominator's in the bottom. You got it, all right? 6 times 6, how about it? 36. And I get 42. Remember I said that was going to be important. So let's keep those numbers in mind. You said we're going to reduce them. We just had it reduced at 6/7. That's why we went here. Make the numbers a little bit bigger so we can test them out. Now the right side, I need a 42 also in the denominator down in the bottom. So let's put a 7 down there, multiply it out. And you know what? Whatever we do to the denominator, we must do to the numerator. It just demands that. By the way, why do we do that? You say, well, look at that. What's 6 over 6 equal to? It's like multiplying by 1. So if you just multiplied by 6 to the denominator over here, you have a problem. So that's why we got to do it here. It's like a 1 popping up here, 7 over 7. A little bit of theory here. You get a little bit of knowledge on Mathline, right? See, some of you thought you knew everything already. Hopefully that came through as a nice new fact. That's why we do that. That's why we do that. Let's go. 5 times 7, 35. And here we got 42. Now we can compare because we're talking about this guy and this guy. One has 36, one has 35. You tell me which one's greater, the one on the left. There it is. That one is the greater because, hey, it's simple. 36 is bigger than 35. You got it. 42s are the same. We don't worry about that. What we're worried about, what's in that numerator? And that's how we tell. That's how we tell. All about multiplication. You got it, folks? All about your times tables. All about times tables. Let's take a look at a quick example here. A little square popping around here. For those of you who want to know, what's the square look like? I have a lot of times people call in Mathline and also in my classes and such, and they're a little confused. Well, you know, they call a rectangle a square, and they call a square a rectangle, and sometimes that's okay, but the square is a rectangle. It is a rectangle. It's a rectangle with all sides congruent, but not all rectangles will be squares, all right? Got that? So in this case, we're talking about a square, and I'm going to put little tick marks here. I call them tick marks because they're all the same size. They're all the same size. They're all 7 feet long, all right? So we'll put a little 7 feet right out there. This question's asking us what's the area and what's the perimeter? Well, you say, well, Ernie, what does that have to do with times tables? It has everything to do with times tables because what's the formula for getting an area of the square? It's the length times the width. Well, the length and the width all happen to be the same. So we can say each side has the same length of 7. So to get the area, we'll call it A. Why not write it out? Area is going to equal 7 times 7. Well, my friends, that's a times table, isn't it? It's a times table. It equals 49. You say, well, 49 what? How about it? Square feet. Square feet there, all right? Now, what are we going to do with the perimeter? Well, the perimeter has distance around, right? So we add all 4 sides. By the way, if it's a square, I want another little lesson here. I tell you, isn't it fun to have a lesson within a lesson within a lesson, teachers? We put these boxes here because they're right angles. That also is a characteristic of a square. We have 4 right angles and 4 congruent sides, all right, 4 of the same length. So I can put a 7 over here, and I'll squeeze a 7 right up there. And it looks like we have a perimeter of, well, some of you say, well, we add 7 plus 7 plus 7, one more 7, add. There are 4 of them. Another way that's even smarter is notice that we do addition. We do addition 4 times. Oh, did you hear the word times there? In other words, multiplication, how do they relate to addition? Multiplication is repeated additions. We're adding 7 4 times. So let's write it as a multiplication. 7 times 4, and that's going to be 28. And by the way, they are just feet. There's no square feet going on with the perimeter. Because you're walking around the distance or you're going around the distance of the exterior part of this figure, and you're not squaring anything. You're not trying to figure out what's inside. That's what area. Area is all that space inside. Perimeter, just what it says, on the outside. On the outside. So there you go. Square feet, 49. 28 feet for your perimeter. All right. So you got it going out there, ladies and gentlemen? I hope so. I hope so. Let's go back to a fraction problem. All right. Let's take a look at this next one here. It says we're going to subtract the we're going to subtract the fractions. So those look pretty or what? 5/9, and we're going to subtract 2/7. Oh boy. Somebody's out there saying, well, do we take 5 minus 2 and then 9 minus 7? No, don't want to do that. Don't want to do that. We've got to have the same number. We've got to have the same number in your denominator. Just like when we decided which one was bigger. I'd like to know if 5/9 bigger than 2/7. Most of you are saying that. well, numbers are smaller in the second fraction. That's not what it's always about. What it's about is what happens when we get a common denominator hanging out here. If I had 2/3 there, I tell you, 2/3 is going to be bigger than 5/9. You say, really? Really? Take my word on that one. We'll think about that on another show, all right? But what we got to do is figure out what is the least common denominator. Now, these numbers, 7 has nothing that will allow it to reduce down. There is no common factors between 7 and 9. So what we're going to do, we're going to take these two numbers. Yeah, 7's a prime, that's right. So 1 and 7, the only thing you can get there. 9, you've got 1, 3, and 9 that will divide into it evenly, but 3 and 7 just don't work together at all. What I'm saying is we're going to multiply 7 and 9 together to get that common denominator here. All right, so let's put a 63 right there. We'll put a 63 right here. Put our little subtraction sign between it. La, la, la. And let's see. What did we do? Well, we multiplied by 7, didn't we, to get that 9 to become a 63, which means put it right up there also. Put the 7 right up above. Over here, we played with the 9. We brought it in. Over here, we need to also play with the 9. So see where we are. See where we are. Let's see which one's actually bigger. 7 times 5 is certainly bigger than 2 times 9. Already a lot of you are saying, yeah, Ernie, that's the way it works, isn't it? It's 35. Right there you go. 2 times 9, 18. You got those times tables down? You're doing fractions. I'm going to tell you something. Those of you who detest fractions, students who are still watching me at this point, today, you know what? Why you usually detest them? Because you don't know your times tables yet. If you know those multiplication tables, fractions, adding and subtracting, multiplying, dividing, it becomes so much easier. It becomes so much easier. You don't waste time going, oh, calculator, brain, oh, I've got to write them down. What do I do? All right. So here we go. We've got 35 over 63. Everybody see where that came from? Because we used 7 times 9. We had 9. We put a 7 to both. Remember, whatever you do to the denominator must be done to the numerator. Over here, same game. Whatever you do to your denominator, which in this case was times 9, you got to do it to the numerator. So there we have it. 35 minus 18. That one we're going to work it and subtract it. And we got 17, looks like, over the 63 goes along for the ride. So there's your story. It's all about the multiplication, isn't it? The subtraction was easy. Bringing 63 over is easy. Multiplying, it's easy. You know your times tables. Got it? You got it? All right, that's what it's about. That's what it's about. Let's take another one example. We're doing fractions a lot today. I told you we would. So here we have it. Let's take a look at our next little guy here. It says multiply the fractions 5/6 times 2/9. Now, sometimes we don't see where we can cancel and make life a little easier for us. So what we're going to do here, what we're going to play off here, is we're going to multiply the numerators together and then the denominators together. So let's see what we've got here. I've got 5 times 2. It's going to give us 10. And 6 times 9 is 54. Now, your teacher's going to say, you can do something with that. And the thing is, you notice that 10 and 54 are both even numbers. By the way, does everybody remember 6 times 9 or 9 times 6, however you want to look at it, commutative property style there? That does give you 54, all right? Now, let's see what happens if we divide 2, because they're even. They're even, so we got to do them both. We can't just do one. Can't do just one. Got to do them both. So that gives me 5. And down here, I split 54 in half. Be careful, because it's going to be an odd number for a result. It's going to give us 27, all right? 27. So 5 over 27, you say, well, Ernie, I don't think anything else will divide out of that. 5's prime. 5 won't go into 27. You're finished, all right? You're finished. Now, let's look at, I said there's another possible way. And it still involves multiplication. You're not going to get out of these times tables, all right, today. That's, so you're going, oh, yeah, you're right. So look on this diagonal. We've got a 2 and a 6. Both of those are even numbers, and they're on a diagonal. Now, I can't do that across, but I could do it up and down. But there's nothing here that's going to divide out or reduce. So let's play it on the diagonal here. And again, if you miss the diagonal moment, you've got it here. It'll work. It'll still work out. But I've got 2 going in there 1 time to the 2, 2 going into the 6. How about it? 3 times. And look what you get. 5 times 1, which is 5. Take your denominators. 3 times 9, which is 27. Same answer. One way you catch it early, not as hard to multiply. Here, you know your times table. It's really not that hard. Divide by 2. All right, so you get the same answer. Life is good. Life is good. Again, it's even better when you know what? All those times tables. Let's take a look at our next one here. Let's take a look at our next one here. Dividing fractions, all right? So we're going to take 5/9. Like I said, it's a review time, my friends. It's review time, remediation. So we're hitting all the operations with the fractions here. Notice I haven't gone to mixed numbers yet. That'll come in another lesson probably this summer, all right? I know those fractions, they're very important. That's why you spend so much time every year of your elementary and many of your middle school years on it, okay? And then in high school, they don't go away, do they? They're still out there for those of you who are from high school. And parents and adults, you still work them in life too, right? Out there, those of you tuning in, college parents, out there in the work field, fractions are still out there. They're not going away. Now, the rule for division. We keep the first fraction as it is. By the way, that is a division. 5 divided by 9. That's what 5/9 or 5/9 means. Over here we're saying 7 divided by 6. But what we've got in the middle is another division. That's the one we've got to worry about. Because when we take that first fraction, we leave it alone, like I said, but we're going to have to make this become a multiplication to see where we're going to go with this. If we do that, it's time to interchange numerator, denominator. Some people use the word invert. I like the word reciprocal. They mean basically the same thing. We are going to interchange our numerator and denominator. So it's going to become 6 divided by 7, or 6/7 with the game plan. Notice, first fraction, no, don't mess with it. Second fraction, have fun with it, all right? Now, let's see what we're going to come up with. I'm going to use my approach. I'm just going to use it straight across some of your approaches. My approach will be, let's do a little cancellation, but we're going to do that in just a second. You got 5 times 6, which is going to give you 30 running across the top. You got 9 times 7, you know that. 63 running across the bottom. I see 3s everywhere, and I see a 0, which means I can divide both of these by 3, which isn't so bad. Because you divide 3 into, what is that, 30? Yeah, it goes 10 times. Divide 3 into 63, well, that's easy too. You get 21. You say, Ernie, what do you mean you talked about a cancellation or something going on? Let's rewrite that. Let's lose the bottom there for just a second, guys. All right, yeah, we got 5/9. Let's do it times 6/7 once again. We start from the same place. That hadn't changed, all right? And by the way, we don't cancel until we change to multiplication. Those of you who are going to try to do what I'm about to do, all right? So let's do our noticing that 6 and 9 are both divisible by 3. It's going to give me a 2 on top, 3 in the bottom. Whoops. Do we get a 10 again? I believe we do. Numerator got a 10 in it. Denominator, 21. You still have the same answer, just got a different way, all right? You still have to multiply, don't you? Still got to know your times tables. Sometimes it makes it a lot easier if you can catch a division before you get too far along, all right? Now, let's sum up one more thing we got here. I've got one more of these which is greater questions. We've been dealing with fractions more today than I thought we would be, but hey, it's fun. And if you're doing well with them, life is good. This one says, let's go with 8/9. Woo, getting them up there, folks, getting them up to big numbers, and 7/8. Again, remember my little hint I gave you earlier. These two numbers are right next to each other, 9 and 8. The only way you're going to LCD, or least common denominator, is multiplying them. So let's do it. Multiply by 8. And if you do it to the denominator, yeah, boy, howdy, you got to do it, what, to the numerator. We got 64 over 72 because, hey, we know our times tables, all right? Now, how about this next one here? Let's extend. Let's do an 8 times 9 because commutative property says hey, it works that way, all right? And let's put a 9 right there. And that looks like, how about it? 63, 72. Which is greater? This guy right there. By the way, they won't reduce down any because, well, would they reduce down? Of course they would, because you go back to 8/9. But that's not what we're trying to figure out, is it? Because we've got to have the same denominator in order to answer this question. I have so many times when students get to this point, they get that 64 over 72. Oh, I'll just reduce it right back down. That didn't help you, did it? You worked together there. You did it for a reason. Use it. Use it. It will help you get through it, all right? And again, our whole thing today has been ways to practice on multiplication. Because again, I keep preaching it. I'm going to preach it again. If you get your multiplication tables down, fractions, decimals, percents, all of those are going to become so much easier, and you'll get some answers quicker than you really thought you could, certainly not by wasting your time on the computer or on the calculator when you got the best computer of them all inside between your two ears called the brain inside your head. So, hey folks, been a great session today. I hope you've learned a few things. We're going to do some more review. We're going to be doing all summer long here. So tell your friends. They want to get this Mathline. They want to be ahead next year when they go back to school in their math. Tune in. Summer school here on PBS. You're going to love it, and we love having you too.